There are a few oddball things in retro computing that I find just absolutely fascinating. I think I've mentioned a couple of them in the past on the channel. I'm really interested in very, very old 3D accelerators, especially ones that are so old they don't have texture mapping support. Yeah, that's right, don't have texture mapping. I'm really interested in very early multiprocessor systems. My first, now it's my maybe my third or fourth PC was a dual Pentium 133. Nobody had multiprocessor PCs at that time. It was great. I loved it. And the other thing that I've always been super interested in is hardware-based speech synthesizers. Always thought that was the coolest thing from the first time when I was in elementary school and I went to a friend of mine's house and he had a TI-99 with the little sidecar speech synth add-on. And I kind of played around a little bit with software speech synthesis in the very, very early days of the channel. But I haven't really done anything with it since then. And I think it's about how high time I fixed that. I've had this book for, I don't know, maybe a year or two, and it has a bunch of interesting projects and has some very cool images of, very primitive both speech output and input devices, talking radio clock. I'd love to find one of those. I think that is kind of cool. Of course, the speak and spell, and this is the super original one here with the actual clicky buttons. I don't know. There's some other neat things in here. Various talking toys and whatnot. Anyway, I've read a bunch of this book and kind of gone through a little bit of it and looked at some of the things. But it wasn't until very recently that I acquired some actual chips. So these are the General Instruments SP0256-AL2, which this speech chip has been used in a ton of, I'll go ahead and zoom in. Whoops, I said in a ton of speech synthesis devices for classic 8-bit computers. And I would like to also do that. And then this pair of chips is a SP0256-017 and an SPR016117. So this is some kind of a serial mask ROM. And this is a version of this chip that was designed for talking radio alarm clocks. And I believe that somehow these two work together. I'm still not real clear on that, but this is the main chip that I'm mostly interested in because this one has a set of 64 allophones built into it, tiny parts of speech that it can be programmed to say, and you program it to say them in sequence, and if you pick the right ones in the right order with the right timing, you get something that kind of sort of almost sounds like words. If you're lucky, maybe you can understand it. Now, I really want to do some projects with these. I want to integrate them with actual classic computers. I know that there are project boards published in magazines to use this chip with VIC-20 and TRS-80 Model 1 and probably some other things. I would like to build one of those devices, and I would like to use it. Here's the thing, though. I have no idea if these chips work. And I don't want to go to a bunch of effort and put together a thing and hook it up to a VIC-20, for example, and connect it up, write custom software for it, because I would probably have to do that, and then have it not work. And then, okay, so is it my software? Is it my hardware that I built? Is it the chip? Is it, death rays from Mars? I don't know. So I recently came across someone on eBay selling boards that advertise themselves as tester boards for these chips. That you build the board, you plunk one of these chips in it, you run their software on it, and it puts it through its paces and lets you know if it works. Lets you know if it works because you hear the sounds coming out that you expect to have come out. So I ordered one of those, and I waited, I don't know, a week and a half or whatever, because it had to come from far away. And it's here. So I'm going to build it, and I'm going to test these chips out. I'm going to find out if they work. All right, here's the box as it arrived from eBay. I think it came actually from, I want to say, Georgia or something. So almost completely the opposite end of the country. It took me a little while to get to this because I knew that I had an Arduino that I had purchased years ago for a completely different project, a homebrewing related project, funny enough, that I just never got around to, and it took me a while to find it. If I couldn't find that, then there was not going to be any point in trying to assemble this kit and then just have it assembled and hanging around. Here's how it came. All right. Bunch of stuff. Oh, the board looks really good. I wonder, speechchips.com. So that's where all the software and whatnot will be. All right. And here are the directions. And then, so presumably, all right, so there are small labels on each socket where each thing goes. And then each specific item is labeled out here, which, as small as this board is, this is definitely the right way to do this. I know that sometimes some other YouTubers will complain that, just label what the actual values are. But, for a lot of these, it's just easier to label the part number and have the list, just because it's so small and everything would be very cramped. So I'm going to assemble this. I don't know how much of the assembly will make it into the video. As I've said many times, my skills are no good, although I do now have a much nicer soldering iron that should work better, but I'm sure I'll still find a way to look like a complete buffoon doing this, so we'll see how it goes. So I'm not sure, so I'm going to start. The usual advice is start with the tallest component. Start with the tallest component or start with the shortest component? Start with the shortest component. Okay, start with the shortest component. Right? Because you want to be able to flip it over and set it down and have the component actually be able to rest on something. Okay, start with the shortest. Let's make sure, organize everything in some fashion. This is an LM386. Volume knob, headphone jack. I want to say 5 capacitors, little tiny ones. Yes, 5 little 0.1 microfarad, 3 10 mic, 1 220. And then these must be in here. Must be the 220 picofarads, the crystal, the LM386. 10 ohm resistor, 3.3K. I guess I can have this on camera. 3.3K, the 1K. This must be the variable resistor, RE1. speaker, headphone, speaker jack, and then the other ports, I'm assuming it's kind of obvious where these will go. I'm assuming they go on this side because at least these ones must, because that's how they connect onto the Arduino. I guess I can look at it and see. Oh, okay, no, so they all go on the bottom side because I haven't even opened this yet. We'll save that. All right. I guess let's just get to it. Those are really tiny. So I may end up regretting having put in these capacitors before having done this chip. That might end up being a little bit annoying, but that ship just sailed when I clipped those leads, but maybe I can revisit that. I'm sure it'll be fine. I'll figure out a way to make it work out. The important part that is frequently mentioned when people are doing soldering jobs like this is to make sure that the notch matches the notches. So I did make sure of that on the socket here. But it's even more important on the actual chip, because the socket, if I got the socket backwards, I could, put the chip in the correct way at least. But with the chip, you have to do that right. On electrolytic capacitors, they have a negative and a positive, so those have to be put in. The other capacitors and resistors can go in either direction, but electrolytics, there is a correct way and an incorrect way. So there's probably also a correct way and an incorrect way to remove them from the mounting. And I'm sure someone's going to tell me that, okay, I'm going to guess that these you should just cut off, because those legs are bent all funny. Now, normally, the positive is the longer lead and the negative is the shorter, but then it's also labeled. So it's signaled multiple ways on this. So on these, the positive leg is to the left on all three of them. So So the speaker is left, and I don't know how I'm going to do that. I probably should have done that very first or very early on, because it is, I don't know. I think I'll be fine with headphones for now. But I think for the rest of these, what I'm going to do is I'm going to open this and I'm going to put these in the mounting holes on this so they'll be held straight, and then I'll mount this onto it and solder it on that way. Well, that does not want to come out. It must have seen how poorly I was soldering. No, don't solder me too. Not like that. Cue the not like this meme. There are a whole bunch of things that happened that I'm just going to file under learning experience. Because the other alternative is weep uncontrollably. All right. So the first thing I learned is my other camera that's up here. It will record 29 minutes and 59 seconds of video, not 1 second more. To solder this little gem together took 35 minutes and change. Okay. I had anticipated that the soldering of all of this would be the hard part because I'm terrible at it. I don't do it a lot. I was mistaken. The soldering was the easy part. On the sheet here that came with it when I ordered it is contact me for software. Well, so I did contact the person, or at least attempted to, and I haven't heard back from him. So I haven't got any of the software from him. And without any software, this is just kind of a brick. Like, it's pretty. All right. But, I figured this is a pretty simple little widget. It's going to connect this chip very directly to the Arduino. Now, I'd never done anything with an Arduino. I mean, on camera, I took this thing out of the package for the very first time. It can't be that hard. I've been professionally working on graphics drivers for 20 years. I ought to be able to figure out how to make a piece of hardware do a thing. Especially a piece of hardware this simple. I've got the datasheet. I know, abstractly how to interface it, how to work with it. But in this specific context, I didn't know. So I started off by searching to see, other people have done projects where they hook up one of these chips to an Arduino. And I found several of those projects, both for the SP0256-AL2 and for the 017. The pinouts of these two chips and the way that you interface with them is identical. The difference between them is what they can say. All right. And there were several different projects that I found for each. And so I thought, all right, well, I'll just crib their code. There is that chance that it could just work. All right. Well, it didn't work. It did nothing. Which was kind of a bummer. Like, it did nothing. So I started by kind of tweaking with it to the software was really simple. It the way that these work is there's a certain number of pins that are the selector of what sound you want it to make, and then you strobe a line that says, okay, look at those other pins to see what I'm trying to tell you to say, and do it. And so they just have a list of, like, here's sounds. For the AL2, it's just, here's a list of sounds, the allophones to try to form some simple words. For the 017, the thing that I found just goes through and tries to make it say all of the things that it can say. These are designed for talking clocks, so it can say numbers and a bunch of alarm clock related things. Okay. So I tried both sets of software for both chips. Bupkis. All right, so I tried modifying it so that in between each thing that it tried to say, it would blink the light. There's an LED that's really hard to see with this hat on. There's an LED under there, and I could see that the LED was blinking, so I knew that it wasn't locking up. Okay, all right. So the best guess is that this is just wired to different I/O lines on the Arduino than those other projects used. So I went through, and because I'm new with Arduino, looking at this sheet I didn't fully grok it and didn't understand. And this is really, really hard to read. This could have been a little bit bigger. That would have made it a bit easier to read. But I went through as part of the learning experience, and also to double check my soldering work, and using my multimeter, I went through and I checked that all of the pins, where they actually connect to the chip, they all toned out fine. My solder joints were fine. All right, so the other projects were configured so that all of the out data, the digital I/O port, altogether was the sound request, the address. So you write that as a single byte, and then strobe the other line and hold the line. It's active low. So you hold it low for some number of milliseconds, and then put it back high. And so that was wired. Those projects were configured that way. They were all using breadboards. They were configured that way to make the software easy. This, being a real hardware project, is configured to make the hardware convenient. So the ordering of, and you can see that a bit on this, the ordering of where the data pins go to where the I/O pins go to the address pins is a bonkers scrambled order. And the reason that it's laid out that way is because that's what made the routing easier. And in some cases, the routing would have had to be really crazy to use a sensible ordering. All right. So I figured out how to get the address lines routed correctly. And still nothing-ish. On the AL2, I would get static, and on the 017, I would occasionally get a number, but it was weird. It didn't behave right. So I thought, okay, all right, there must be some other pins. Like was fairly sure that I had this wired up correctly. And so one of the things that I tried is, all right, well, maybe I have the order weird, right? I don't have the order right. So I thought, okay, I will have it alternate between saying the phrase that is all zeros, which on the AL2 is the short pause. I think it's the 10 millisecond pause, and the thing that's all ones. And I don't, it was actually 3F. And I don't remember which sound. I think that's like the B, like in bounce sound. And just alternate between those in an infinite loop. And it alternated between like two different kinds of static. Like, well, okay, well, something's happening. All right, so I dug a little bit deeper. And what I found was this is designed to be a test board. So everything that this chip can do is accessible from the Arduino. I looked at the other projects, and a lot of things were either permanently wired to ground or permanently wired to positive voltage. And so I dug into the datasheet, and there's two different ways that you can address this depending on how one of the pins, which one is it? The SE pin is. If SE is low, it's this weird mode that I've read the documentation for it, and I don't... Basically, it takes a value when one of the pins changes from low to high. And I don't, just looking at how it described what it does, I don't understand how that's useful ever. I don't know. Maybe there's just something I'm not getting. But the other mode is the mode that the software was trying to actually use, was assuming was how it worked. So I modified the setup routine to do a bunch of things. One, I modified it to make sure it was doing all the reset-y stuff properly. I modified it to set SE to high to do the kind of addressing that I wanted, and then set the test pin low. And it's interesting because in the datasheet, it doesn't say anything about what the test pin does. However, the way that this board is configured, the test pin is also the blinking light pin, so I could toggle that on and off and see the blinking light do something. Pulled that to low, and there's probably a couple other things that I adjusted. I'm trying to remember what all. Anyway, going through, bouncing back and forth between the two chips, and then finally, after a lot of stuff, I managed to get it to actually do something. So, hello world. So yay! It can say hello world. Hello world. All right. Well, that's pretty neat. So I tried that, and then here I also modified it to say something else, just to make sure that. Right? I mean, come on. You knew that was you knew that was coming. All right, so that was great. And then I played around with this using different software, and I'm going to do a cut here because I want to show what that does, because it's not really what I was anticipating, and I'll show that here in just a moment. Okay, so with the chips swapped and the software swapped, this one also talks. I was very happy that I got these out of just a parts bin at an estate sale. I had no hope that they actually worked, so I paid, I don't know, $0.25 a piece for them.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3.
Okay, so it'll say 0 through 10, just fine, exactly as expected. 11 is, and then it just goes bonkers after that. So I spent a lot of time trying to debug this. Debug the software, debug the board, like, okay, what is wrong? And then I stumbled across someone's note on one of the projects that use this that says, oh yeah, 0 through 10 work just fine, but 11 hangs, and then nothing after that, unless you have the extra ROM wired in. There's a way that it's a serial ROM, connects to some of the other pins, and then you can, so when it gets to, basically there's only so much ROM in here, and it couldn't hold all of the numbers and the phrases and the other things. I think there's some little songs that it plays, which I thought was a little bit bizarre, but whatever. I don't judge. I mean, I guess it's an alarm clock, so maybe it wants to, chirp at you like, oh, hey, time to get up. It's too early to be cheerful. If the alarm's going off, it's too early to be cheerful. So without this connected to these other pins, you can't get those other things. I suspect, and it's going to depend on how much time I have, that it should be possible to basically jumper wires out from this out to a breadboard and connect the two of these together on a breadboard to be able to get the other numbers. But the main thing of this is that I wanted to be able to test these chips and any future chips like this I get so that I can, use these in other projects, because I do want to build some things with this. So finally, with all that, I'm gonna put this in the W column, but it was not super easy getting there. I'm going to make the software that I wrote available on GitHub. There will be a link to it below, and it contains a little bit more documentation about this specific board in case someone wants to order one of these from the guy on eBay and he doesn't. I don't know. I'm a bit confused about this whole thing because the website seems completely DOA. Although Googling around on the net, this used to be a thing, and there used to be all kinds of stuff there and various things archived, and it seems to have just fallen apart, which is kind of a bummer. Anyway, I will make my stuff available to make this stuff work. All right. So I did exactly what I was saying that I would do. I have omitted a step from videoing, which was just connecting all of the wires from here to over here and verifying that the chip works as before in this. I say this in a lot of my videos. This is the thing about engineering. Limit the number of variables, limit the scope. Because if I had wired all this up and it didn't work, okay, well, what part is screwed up? So, make the tiny changes, make them very small and incremental. Okay, so I did that and it worked as before. And now I've wired this up in the obvious way. The ROM disable pin goes to the ROM enable pin. The C1, 2, and 3 go to C1, 2, and 3 over here. Serial out from this chip goes to serial in of this chip. Serial out of this chip goes to serial in of that chip. And I wired all of the other active high enables to power, all of the active low enables to ground, power and ground. Everyone's wired up. And so hopefully this is just counting and going through all of the steps and and I'll be happy.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
Yay!
15, 16,
All right.
17, 18, 19, 20, 30, 40, 50. It is AM, PM, hours, minutes, 100 hours. Good morning. Attention, please. Please hurry.
All right. Well, it all seems to work just fine. The chip and the extra ROM chip. Yay! Not bad for.
1, 2, 3.
Whoops. Not bad for, I don't know. I think I figured out, because I bought a bunch of stuff at that. I kind of figured out that I paid about $0.25 per chip. So not bad. They came out of a random box of junk and they worked. Yay! So if you've enjoyed this video, please click the like and subscribe buttons. These chips will make a future appearance. They will come back at some point in some project. I've got a couple project ideas for that Heathkit 6800 based computer, and these would be awesome. I also have some software ideas for software that would run on a modern computer to generate data to feed to these. But I think that's going to be a bit more of a long-term project. So, until next time, try to remember the good stuff.